Hello and welcome to Revision Tips for SIPS Level 5, Advanced Diploma in Procurement and Supply. This is Module 9, Operations Management, and it's Learning Outcome 2, which is to understand improvement methodologies that can be applied in operation management. So we look at the tools for improving performance, the techniques in failure prevention and recovery, the role of total quality management, and different techniques for quality improvements that all can be applied in operations management. So what we're looking at here is a balanced scorecard that was by Kaplan and Norton. It does include financial performance measures, but it also includes other measures that represent the organisation, its strategy and its overall objectives, enabling the measurement of a full range of activities and processes. So it focuses on four key questions. How do we look to our shareholders? That's the financial perspective. How do our customers see us? That's the customer perspective. How can we change to improve? That's the learning and growth perspective. And how efficiently are we working internally? And how effective are we? That's your internal process perspective. So the balanced scorecard approach gives a more comprehensive picture of the performance of an organisation. This leads to better decision making, focused on improving the whole organisation rather than parts of it. So this comes up a lot. This is again the 5 performance objectives coming from Slack that suggests all operation functions can apply these 5 performance objectives in an integrated manner, making trade-offs to find the most optimum mix of KPIs in order to achieve the highest level of customer service. So an example, the clothing retailer Zara uses a mix where the speed to market, production flexibility and logistic dependability take precedence over quality, fit for purpose only, and cost, some level of production capacity forsaken to maintain agility. But note, price is not a performance objective, as these are internally focused. So let's start by looking at setting performance targets. Measuring the performance of an operation is a fundamental part of business management. Each of these performance objectives were discussed in session 1 that can be measured. And each of these performance objectives can be broken down further and measured. There are a number of approaches that can be used when you're setting performance targets. So firstly, you can look at historically based targets. We compare current measures with those we've achieved in the past. Strategic targets is where we set targets to reflect how the operation is doing against strategic aims and objectives. Externally performance-based targets. This is where we set targets to match or exceed the performance achieved by a competitor, external operation, or a recognised performance. Some sort of standard within the industry like benchmarking. And the fourth is absolute performance targets. This is based on a theoretical upper limit of performance like 0 defects or 100% on time in full. But as you can see on the screen, your targets need to be SMART, specific, measurable, achievable, relevant and time-bound. So let's have a look at benchmarking. It's the process used in management in which organisations evaluate various aspects of their process at the strategic and operational level against current best practice. This then allows organisations to develop plans to bridge gaps in performance. Benchmarking may be a one-off event, but it's often treated as a continuous process in an organisation who is continually seeking to challenge their practice. The aim is to sustain superior performance within the organisation. But there are different types of benchmarking. You've got performance benchmarking, which arises when one part of the organisation compares its performance with other parts in the same organisation. So a good example would be where one company in a group of companies compare itself with other members of the group. The obvious disadvantage to this form of benchmarking is that practices within the group may not be able to see any better than the best examples found outside the group. So you can use competitive benchmarking instead, which occurs when competitors agree to benchmark their processes. There is an obvious reluctance to do this in many cases, as it can, in any case, be difficult to identify emerging competitors. The third is external benchmarking, when you basically compare your function, like purchasing and supply or finance and personnel, with similar functions in other possible dissimilar organisations. And then non-competitive benchmarking is the opposite of competitive benchmarking, where comparisons are made against organisations that are not in direct competition. When planning for improvement of operations, importance must be placed on customer perceptions and preferences and needs, and how competitors are performing in their operation. The sandcone theory illustrates that there are measures with quality as the foundation as the highest priority. But overall, reduction in cost results from improvements in all measures. While it's important to focus simultaneously on all 5 measures, quality, dependability, speed, flexibility, and cost, a minimum level in each must be reached before moving to the next. So moving to the next priority should lead to a greater improvement of the previous measure. The way the organisation looks at improvements will lead to developing an improvement culture, which consists of improvement capabilities and learning. But the 5 phases of benchmarking start with the planning. Understand what you're trying to benchmark. You go off and do your analysis to find the competitive gap. You integrate with your functions and goals and actions. And then you action any specific recommendations. And then the final stage is maturity, where a leadership position is obtained. But how do we build continuous improvement? These are the 2 improvement cycles and tools. The improvement cycles are the practice of conceptualizing problem solving as a performance improvement in teams. And in some ways, it's a never-ending cycle. So on the left, you've got PDCA, Plan, Do, Check, Act. And on the right, you have the Six Sigma DMIAC cycle, Define, Measure, Analyze, Improve, and Control. So if we start with PDSA, this comes from Deming. Plan, Do, Check, Act, perhaps well known as one of the best improvement cycle models. And Deming believed the adaptation and adoption of and action on the 14 points was a signal that management intended to stay in business. He also encouraged a systematic approach to problem solving and promoted this widely used PDCA cycle. Sometimes it's known as the Deming cycle, but it was developed by a colleague of Deming. It's a universal improvement methodology with the idea being constantly improving and thereby reducing the difference between the requirements of the customer and the performance of the process. It's about learning and ongoing improvement. Learning what works and what doesn't in a systematic way, and the cycle repeats. After one cycle is complete, another cycle is started. And on the right, you've got the Six Sigma tool, which we'll discuss a little bit later. Now, re-engineering is the systematic starting over and reinventing the way a firm or business process and gets its work done. Defined by Michael Hammer and James Champy, it's fundamental rethinking and radical redesign of business processes that achieve dramatic improvements in critical measures of performance like cost, service, and speed. The idea behind re-engineering is to make the company more flexible, responsive, and efficient, and being effective for all its stakeholders, which does include your customers, employees, and owners. But in order for it to work, the business must be willing to make radical changes. Business process re-engineering is a management strategy originally pioneered in the early 1990s, focuses on the analysis and design of your workflows and business processes within an organization. Radical redesign of business processes may be necessary to eliminate any unnecessary steps and reduce cost. whereas business process is a series of steps required to complete a task within an organization, such as a restaurant making a meal involves a number of steps. So Champion Hamper first referred to re-engineering in their book, Re-engineering the Corporation, and it has to be done. But sadly, they reported that despite the success of the stories, many companies had begun re-engineering but didn't succeed at it. The unscientific estimate is that as many as 50 to 70% of organizations that undertake a re-engineering effort do not achieve the dramatic results they intended. And this is because they see it as a cost-cutting exercise rather than true engineering of the business. So business re-engineering process is fundamental rethinking and radical redesign of your processes to achieve dramatic improvements in critical contemporary measures of performance, such as cost, quality, service, and speed. Business process re-engineering is the philosophy that recommends the redesign of processes to fulfill designed and defined external customer needs. Or you could say it's the critical analysis and radical redesign of your existing business processes to achieve breakthrough improvements in performance measures. But failure is often associated with negative consequences. But it may also be an opportunity for an organisation to improve their products and services and ultimately improve customer satisfaction and sales. The types of failure. Firstly would be a design failure. This occurs when designs are tested practically. It can occur for two reasons. Underestimated design, like a hospital cannot cope because there are more patients than anticipated, or unexpected circumstances, like water production lines experiencing a demand for different sized bottles, which makes the line become slower and break down. It could be a facilities failure. This could be because of buildings, equipment, machinery, or IT systems, for reasons like wear and tear. This may be either of, a complete breakdown where the machine stops working completely, or a partial breakdown affecting only certain aspects of the facility and only affecting operations for a limited time. The third type of failure is a staff failure that results from errors or mistakes. It could be human error, staff member miscalculating the quantities required for an order, abuse of a procedure like failing to carry out scheduled maintenance of machinery, causing issues that lead to ill health or health and safety risks. Or a supplier failure. Suppliers may fail to deliver the products or may deliver substandard materials. So if a supplier is delivering goods at a lower specification that was ordered, that could result in a failure. You then have customer failure. This is when customers do not use the products as they intended or directed, like not following the specification for power sources of electrical gadgets, or customers being incompetent or lacking information to use the product or service. The burden falls on the organisation to train and educate customers about the use of products, using a user manual. Or you have the organisational failure, which occurs when organisation processes and procedures are ineffective in providing the necessary mechanism for guidance of people at work, such as poor design of processes leading to limitation of performance, or overemphasis of initiatives and rewards leading to a lack of focus by staff, or overemphasis of initiatives and rewards leading to a lack of focus by staff on good business practice and risk management, environmental distribution, or disruption of some description. And that is a potential threat to an organisation's operation that is external, like politics or geographical, social, economic, or technical factors, from the physical environment like an earthquake, or just economic slumps, political unrest, or change of legislation or data breach. So in order to answer the why did it fail question in a useful manner, we need to determine the sequence of events that led to the failure. The root cause analysis is a process to determine the chain of events. The cause may be faulty materials or assembly, design or damage. It also includes poor decisions and human error. Generally, we look for the physical, including human or chemical reason for a failure. But we should also be exploring design, assembly, supply chain, and customer-related processes for where did the error or weakness in the process contribute to the failure. So failure detections can be conducted through checks, interviews, surveys, and questionnaires. In-process checks, process diagnostics, point of departure interviews, phone surveys or focus groups, complaints, feedback cards, or even questionnaires. But the types and causes of failure could either be a total failure in the complete lack of ability of the product or service to perform or fulfill its function, a partial failure where the item doesn't work as expected but has not completely failed, a gradual failure which takes place progressively over time, can often be anticipated on or built up, or a sudden failure which occurs unpredictably and is not easily planned for. But the failure rate is calculated as the number of failures over a period of time. So, for example, the security of an airport can be measured by the number of security breaches per year, and the failure rate of an engine can be measured in terms of the number of failures divided by the operating time. It can be measured as a percentage of the total number of products tested, or as a total number of failures over time. Now, FMEA, or failure mode and effect analysis, is a systematic approach for identifying likely failures in products or services, as well as in business processes such as manufacturing or product assembly. So FMEA may be performed at different stages throughout the product or process lifecycle, depending on the organization's needs. It may point out where there's been a failure and identify ways to detect the failure before they happen. But there are two types of FMEA. The design one is the first, and it's aimed at assessing the likelihood of faults. And secondly, a process one, which detects malfunctions that affect things like the quality of the product, time limit production of the function, and the safety, which may be compromised by human error, manufacturing processes faults, the machinery and materials, and other factors that affect performance of the process. So early detection of failure will lower the cost and reduce product or process risks, give more options to fix the problem and reduce the risks, allow time and opportunity to verify and validate any changes required in a more coordinated effort between product and process design. But the steps for performing the FMEA is number one, you need to identify the potential failures, then establish the degree of severity. Third, evaluate the probability of the occurrence. Fourth, detect or prevent the failure. And finally, you calculate and assess the risk priority number using the occurrence of the failure, the degree of severity, and the likelihood of detection. And as you can see from the diagram on the slide, you multiply them one by the other to give you the risk priority number. Now, the simplest maintenance strategy is to execute run to break down to maintenance, also known as a run to fail. In this strategy, assets are deliberately allowed to operate until they break down. At that point, reactive maintenance is performed. Preventative maintenance is maintenance that is regularly performed on a piece of equipment to lessen the likelihood of it failing. It's performed when the equipment is still working, so it doesn't break down unexpectedly. And condition-based maintenance is a maintenance strategy that monitors the actual condition of an asset to decide what maintenance needs to be done. Compared with preventative, this increases the time between maintenance repairs because maintenance is done on an as-needed basis. But the purpose of maintenance is to ensure the maximum efficiency and availability of your equipment, utilities, and facilities at optimal costs under satisfactory conditions of the quality, safety, and protection of the environment. Maintenance was long considered as a subordinate function, entailing an inevitable waste of money. There was a tendency to lump it together with troubleshooting and repairing machinery that was subject to wear and tear. But the overall purpose of maintenance is to optimize the performance of an equipment by preventing breakdowns and failures. But each approach is suitable to a different circumstance. Many organisations operate mixed maintenance strategies. Here you can see the positive effects of preventative maintenance in that it increased effort that will prevent repairs being necessary should repair costs and therefore add value. Maintenance managers try to make the trade-off between the two basic options that will minimise their combined cost. With no preventative maintenance, breakdown and repair replacement costs will be tremendous. Furthermore, cost of lost production and wages. The age and condition of equipment, the degree of technology involved, the type of production process, and similar factors entered into the decision of how much preventative maintenance is desirable. But as you can see from the diagram on the screen, there's a point where the total cost is at its minimum, and that is the amount of maintenance that a business should be conducting. So failure rate and failure distribution. For example, the security of an airport, as I said earlier, can be measured by the number of security breaches per year, or a failure rate of an engine can be measured in terms of the number of failures divided by its operating time. So measuring failure, there are three ways to measure failure. The failure rates, i.e. how often does it occur. Reliability, the chances of the failure occurring. And availability is the amount of available useful operating time. Failure rate and reliability are different ways of measuring the same thing. The propensity of an operation or part of an operation to fail. Availability is one measure of the consequence of failure to the operation. So failure rate is calculated as the number of failures over a period of time. And what you can see from this curve is it describes the failure probability of a product, service, or process. It indicates relatively high probabilities of failure at the beginning, and then again at the end of the life cycle, hence the name. The curve describes failure probability, and it's looked like they call it a bathtub curve because it's got obviously two sides to it. So the comprised three distinct stages is the infant mortality, which is the early stages of life, where early failure occurs because of a defective part or improper use. But in the normal life stage, the failure rate is usually low and reasonably constant, and normally by normal random factors. But when it gets to the wear out stage at the end of life, the failure rate increases as the parts approach the end of its working life, and failure is caused by aging and deteriorating parts. So business continuity is defined as the capability of an organisation to continue delivery of products or services at an acceptable predefined level following the disruptive incident. And business continuity management is a more holistic process that identifies potential threats to an organisation and the impacts to business operations of those threats, if realised, it might cause, which provides a framework for building some sort of resilience with the capability of an effective response that safeguards the interests of its key stakeholders, reputation, brand, and value creating activities. It's not a disaster recovery because business continuity enables an organisation to operate during and after a disaster. Many of the ideas behind failure prevention and recovery are incorporated in the growing field of business continuity. This aims to help organisations avoid and recover from disasters while keeping the business going. So as operations become increasingly integrated, the increasing dependency and integrated technologies like IT and critical failures can result from a series of related and unrelated events and combine to disrupt totally a company's business. These events are the critical malfunctions which have the potential to interrupt normal business activity and even stop the entire company, like a natural disaster, a fire, a power or a telecommunications failure, corporate crime, theft, fraud, sabotage, computer system failure, a bomb blast, a scare or another security alert, or even a key person leaving or becoming ill or dying, a key supplier ceasing trading, contamination of your products and processes. The list is endless. So two very useful definitions are provided. It can encompass succession planning, supply transitioning, and IPR issues. So it covers three broad areas: people, systems, and assets. We need to expect the unexpected. Now, TQM, or Total Quality Management, is a management methodology to deliver customer satisfaction by ensuring that all employees work to deliver value to customers while minimizing costs from poor work to product failure. All employees, departments, and levels participate in delivering and improving product service. It's integrated into the company culture, strategy, operations, processes, and regulations. It's based on 8 key principles, which you can see on the screen. Customer focus, involvement of your employees, process-centered, integration of systems, strategic and systematic approaches, fact-based decision-making, communication, and continuous improvement. It brings many benefits, ensuring superior quality and design of products and services, which increase customer satisfaction and loyalty. It can thereby lead to higher revenue and productivity levels in an organisation, at the same time enabling organisations to reduce waste and inventory. So some approaches to this could be using just-in-time, which obviously looks to minimise waste and increase efficiency by ensuring that goods are delivered only when they're needed. Or SPC, statistical process control, which assesses and controls quality by monitoring data in the manufacturing process. TPM is total productive maintenance, which looks to maintain equipment in perfect production condition by minimizing defects, breakdowns, accidents, and disruptions. And then quality circles, which aim to improve quality, safety, and productivity and minimize the cost incurred. Or QFD, which is quality function deployment, which defines customer needs, translates them into engineering specification, and designs processes to produce products and services that meet customer needs. It looks at 4 stages: product definition, product development, and process quality control. And in Kenzie engineering production system designed to deliver products and services that meet customers' aesthetics and performance expectations. So TQM can be viewed as a logical extension of the way quality relating practice has progressed. Originally, quality was achieved by inspection, screening out defects before they were noticed by customers. But the quality control concept developed a more systematic approach to not only detect, but also treat quality problems. Quality assurance widens that responsibility for quality to include functions other than direct operations. But it's also about increasing the use of more sophisticated statistical techniques. So TQM includes much more of what went on before, but developed its own distinctive feature. So inspection is the process of measuring, examining, and testing to gauge one or more of the characteristics of a product or service, and the comparison of these with specified requirements to determine conformity. Products, processes, and various other results can be inspected to make sure that the object coming off a production line or the service being provided is correct and meets the specification. Quality control can be defined as the part of quality management that's focused on fulfilling quality requirements, while quality assurance relates to how process is performed or how a product is made. Quality control is more about the inspection of the quality management. An alternative definition is the operation techniques and activities used to fulfill requirements for quality. But quality assurance can be defined as a part of quality management focused on providing confidence that quality requirements will be fulfilled. The confidence comes and provided by quality assurance is twofold: internally to the management, but also externally to the customers and third parties. An alternative definition is that all planned and systematic activities are implemented within the quality system, and that can be demonstrated to provide confidence that the product or service will fulfill requirements for quality. So total quality management is an extension of these activities. And although the quality gurus seem to recommend different solutions to bring about improvement, they're all talking the same language, but they use different dialects. So the notion of quality management was introduced in 1957. It was then developed further by several so-called quality gurus, but each guru stressed a different set of issues, from which emerged the total quality management approach to operations management. To understand the origins, it's worth briefly describing the contributions from these quality pioneers. So if we start with Deming, the 14-point quality plan, or Deming model of quality management, a core concept on implementing TQM, is a set of management practices to help companies increase their quality and productivity. These total quality management principles can be put into place by organizations to more effectively implement total quality management. And as the total quality management philosopher Deming work, this was the foundation to TQM. Then you've got Crosby. Crosby considered to be one of the most highly regarded of the modern quality gurus. He developed a quality management maturity grid. This was a 5-point progression of awareness in the application of quality and quantity thinking. Crosby said there are 5 absolutes of quality management. Quality is conformance to requirements. It's prevention, not appraisal. The performance standard must be 0. The measure of quality is the price of non-conformance, and there is no such thing as a quality problem. So he's best known for his work on the cost of quality. He suggests that many organisations do not know how much they spend on quality, either in putting it right or getting it wrong. And he claimed that organisations have the measures, that they measure their costs that equate to about 30% of sales. Others suggest a much smaller figure of about 10%. But he tries to highlight the cost and benefits of implementing quality programs. Then you've got Juran, Joseph Juran, defining quality as fitness for purpose in terms of design and conformance, availability, safety, and use. His concept more closely incorporates the viewpoint of the customer. He's prepared to measure anything that relies on systems and problem-solving techniques. Unlike Deming, he focuses on a top-down management and technical methods rather than worker pride and satisfaction. He pointed out that a dangerous product could conform to specifications but would not be fit for use. But he tried to get organisations to move away from traditional manufacturing that's based on quality as conformance to specification. And then Taguchi at the bottom looked at the quality loss function and focuses on robust design. But there are steps in creating the cause and effect diagram, which is what you can see on the screen. It's sometimes referred to as Ishikawa's fishbone. What it basically says is you need to write down the quality problems being investigated. In the case on the screen, it's about wielding defects, which is the backbone, the straight line in the middle. Then you identify the possible causes of the quality problem. So is it the measurements, materials, the personnel, the environments, the methods, or the machines? The third is a breakdown of the identified causes of the quality problem into more detail. So it's possible that causes are defined in order to, well, they need to be identified to solve the problem. And the incorrect measurements may be due to visual inspections, non-destructive testing, or even destructive testing. And they could be further detailed if possible, continuing until each cause is broken down into the final detail. I would also say to support this with using something called the 5 whys. That helps you get to the root cause of a problem by asking the question why 5 times. Now, statistical process control is an industry standard methodology for measuring and controlling quality during the manufacturing process. Quality data is the form of product or process measures, and they're obtained in real-time manufacturing. But the data is plotted on the graph with predetermined control limits. Control limits are determined by the capacity and capability of the process, whereas specification limits are determined by client needs. So the control chart is a graph used to study how a process changes over time. Data from samples are plotted in time. The chart records the average of a small sample and not individual results. It's not inspection. So an X-bar control always has a central line for the average. That's the top graph. An upper limit, which is the upper control limit, and the lower line is for the lower control limit. The R chart at the bottom will have an upper and lower limit. By comparing current data in these lines, you can draw conclusions about whether the process variation is consistent in control or it's unpredictable and out of control with some special cause of variation. Data should be used with limits and not have the run of non-natural points, i.e. below average, or a run of such 6 successive increases or decrease in values. If there is a special cause variation, the process will be stopped by the operator, usually before defects of parts can be produced. The problem will be rectified and the process will restart. The method is therefore detective prevention in nature, unlike inspection. So by plotting the results on the chart, we can monitor the variations. Common causes of fluctuation are caused by unknown factors, resulting in steady but random distribution. It's a measure of the process potential or how well the process can perform when special cause variation is removed. So unlike common cause variability, special cause is known for known factors that result in a non-random distribution of outputs. Special cause variation is a shift in output caused by a specific factor, such as environmental conditions or process input parameters. It can be accounted for directly and potentially removed as it's a measure of the process control. So the fourth of those gurus that we mentioned earlier looked at the Taguchi loss function, and that suggests that quality does not suddenly go bad and that costs do not raise out of nowhere. Instead, poor quality and costs are the consequence of deviations from variations from the predefined targets of optimal quality levels. So as the target quality level, I suppose if it's at 0, but are progressively rising as the product or service deviates from that predetermined target, you'll see that loss function as it shows on the screen. You have nominal value, which is the target quality value, which is midway between the upper and the lower satisfactory quality limits. The smaller, the better. The perfect target value for quality or the best quality standard is obviously 0. The larger the better, the higher the value attained, the better. So what you can see here is, these 1, 2, 3, 4, 5s, which show things that are very good, good, okay, poor, and unacceptable. And you need to be viewing that as part of your process control so that you prevent it from ever getting to that sort of unacceptable standard. And then you've got Poka yoke, something that is fail-safe is designed to be made in such a way that nothing dangerous can happen. If the part goes wrong, you've got fail-safing based on the idea that human mistakes are, to some extent, inevitable. The key consideration is how to prevent those errors becoming defects. So Poka yoke is a mechanism that helps to avoid mistakes. Its purpose is to eliminate product defects by preventing, correcting, and drawing attention to human errors as they occur. So you can see here that the plugs will only fit in to the bottom one because of the way the holes are measured. It won't actually fit into the top one. So it's made in such a way that prevents the error from happening. So examples from manufacturing is to limit switches on machines which allow the machine to operate only if the part is positioned correctly. Gauges placed on the machine through which the part has to be passed to place on a load or to be taken off the machine, or light beams that activate an alarm if positioned incorrectly. But in the service context, you could be color coding cash register keys. The McDonald's French fry scoop, which picks up the right quantity in the orientation and then goes in the pack. Or trays with indentations for food, ensuring that all items are present. And then Six Sigma. Six Sigma is a quality management approach for attaining improvements in products, services, and processes by identifying and eliminating defects. The six goals of Six Sigma is to eliminate variations and deliver near perfect products, services, or processes, resulting in customer satisfaction. That leads to customer loyalty, higher revenues for the organization. So key concept is it's critical to quality. They're the attributes that are most significant to customers. It's about defects. There is a product or service that doesn't meet their product or their service expectations of the customer. They look at process capabilities. That is what an operation process is able to deliver. Variations from what the customer expects, and stable operations, which ensures consistency and predictability are integrated into your operation so the customer can feel safe and valued and know what to expect. So Design for Six Sigma, this is a discipline of delivering products and services and processes that match the process capability and the needs of the customer. The three core principles of Six Sigma is smaller is better, large is better, and normal is best. And the two methodologies are the DMIAC and the DMADV. I mean, we focus mostly on DMIAC, which is define, measure, analyze, improve, and control. But the other one is define, measure, analyze, design, and verify. You would use it in different situations. So define the problem, measure the quality of the problem or quantify the problem, analyze the data and the root cause analysis, set about your improvements and verify the situation, and then control it, maintain the situation. And that is the end of Learning Outcome 2. Thank you for watching.